inspection is probably one of the more dynamic portions of the inspection that you're going to have. And it's also, as we know, part of the big three, the three most expensive items that you're going to find on a commercial property: that, the roof, and the parking area. So when we're looking at the HVAC system as this complex animal that we're going to see, you need to try to identify what it is you're inspecting. Behind me is one of the key components of our system on this building. We have a cooling tower attached to a series of pipes, heat exchangers, pumps, and ultimately heat pumps in each of the suites of this 12-story building. The cooling tower behind me is basically a water-sourced heat pump system where we're taking water, flashing and moving the heat from the interior of the building, and eventually producing the heat up in the atmosphere, all the while being able to push the heat away from the interior of the building, thus cooling the building. So moving through this entire system is a series of pipes and water, both water input into the individual units and out from those units up into the system. So with that, I think what we need to do is walk through each of these key components. Now, before we do that, understand that you would have seen this piece of equipment during your research phase and know this is here. This is a large system that is best left to specialty consultants. And so for the purpose of this video, we're going to talk about the components in a very broad sense, that your specialty consultant will actually help you, if this is something that you do, really diagnose and deduce down these components into their subset. But with that, let's take a look at this system. Within this system, you're going to see a series of pipes. We have open loop pipes and closed loop pipes. The open loop we'll see is the red pipes behind us, and that's open to the atmosphere where we're expelling our heat from the system, and our closed loop, which is the tight system that is going in and out with the cool water. There's typically about a 10-degree difference between the supply and the return, or the open and the closed side. And that's all within where the parameters are on the inside of that cooling tower. If you were to look at a cutaway of a cooling tower, it's dropping the moisture or the water, and as it drops through these cells, it's taking the large drops and making them smaller drops and atomizing it. And as it atomizes, it's actually producing or offing that heat up to the atmosphere. And through evaporation, by the time that water hits to the bottom of that cooling tower, it actually is cool and is being used to pump through the rest of the building to be used as that catalyst of heat movement from the interior to the exterior. Over my left shoulder, I'll see a series of pumps and motors, and that's pulling the water back from each of the floors up across our heat exchanger. Inside of that heat exchanger is a series of tubes, and that water from the cooling tower is circulating those, and that moisture is again taking the heat and expelling it out to atmosphere, and then it moves back into the cooling tower and cycles back over again. Where we'll see this water flow best is on the other side of the cooling tower, where we'll actually see the pipes as they go in and out of the building, or up and down through each of the floors of the building.